తొందరగా Hello, good afternoon. Are you able to hear my voice? Is it audible? Yes, yes. Okay. Now we start today's class. Now, before going to start the today's class, first we'll discuss about what we have done in the last class. Yesterday, we have started the multiple integral topics after completion of improper integrals. In the multiple integrals, we have seen the double and triple integral. And we have written the method of evaluation of double integral on. After that, we have done 3 problems. Now we do the continuation of the problems. Problem number 4. We are in multiple integral topic and we have done 3 problems. Its continuation, problem number 4. Yesterday's class continuation, 4th problem. The value of the integral double integral over r x y square dr, comma, where r is the triangle, r is the triangle, with vertices at 0, 0, comma 2, comma 0 and 2, comma 1, comma is. The value of the integral is. So we are given integral. In the given problem, we are having two integral sign with respect to different variables because dr is dx dy. It is a double integral. If we compare this problem with the first three problems, you will get some difference on. You can find the one difference on. What is the difference? What is the difference between this problem and first three problems? That is yesterday's class three problems only. The main difference is in the first problems limits were given, second problem limits were given, and third problem also limits were given along with the integral. But in this problem limits are not given. It is a main difference only. Always the limits of the integral may not be given. Always the limits of the integral may not be given. Instead of giving the limits of the integral, the region of integration is given only. Instead of giving the limits of integral, region of integration is given. Already I told that single integral will be evaluated along the coordinate axis, along the x-axis or along the y-axis or along the z-axis. Single integral will be evaluated along the coordinate axis. In the same way, double integral will be evaluated over the coordinate plane. On the coordinate plane, we can obtain the projection of the surface of the object. So R is a region on xy plane. That region is the projection of the surface of the object. So double integral will be evaluated over the coordinate planes. Similarly, triple integral will be evaluated over the volume regions. So three integrals. Remember one is single integral, that is ordinary differential integral, will be evaluated along the coordinate axis. That may be x-axis, along the y-axis, or along the z-axis, or along the t-axis. Double integral will be evaluated over the coordinate planes. That may be xy plane, yz plane, or xz plane. Similarly, the triple integral will be evaluated over the volume regions. That's all. So here, for given integral, we are given the region of integration, not limits of integral. Whenever the region of integration is given, we try to draw the diagram from the given region of integration. From the diagram, we try to find out the limits of the integral so that we can evaluate the integral. You will find this type of problems in vector integration. The vector integration is one of the subtopic of vector calculus, right? Now, let us do the problem. Let I equal to given integral, double integral over R, x, y square, dr. Here dr is dx, dy, comma, where R colon triangular region, R such that triangular region, O, A, B. And O equal to 0, 0, comma, A equal to 2, comma, 0, and B equal to 2, comma, 1 only. R is a region, the two triangular region with three vertices only. With the given three vertices, we draw the diagram, and from the diagram, we try to find out the limits only. Let us draw the diagram. X-axis, Y-axis, origin O. One of the vertex is at origin 0, 0 only. Next vertex is at 2, 0. In the coordinate of a point 2, 0, y coordinate is 0. Whenever y coordinate is 0, this point lies on x-axis only. and x coordinate is positive. So this point lies on positive x-axis. It is at 2, 0 only. So this is at 2, 0. Next, other vertex is 2, 1. X coordinate is 2, y coordinate is 1. Both are positive. This point lies in first quadrant. At x equal to, the y height is 1 only. At x equal to, y height is 1. That's it. B 2, 1. It is a triangular region. Or is a region. Up to here, drawing the region is completed only. Drawing the region is completed only. Now we write the equation of the line segments of the triangular region. The y-axis equation is x equal to 0. It is a line segment at x equal to 2 only. And the equation of x-axis is y equal to 0. Equation of this line segment is x equal to 2 only. Next equation of this line segment is, by using the 2-point formula of straight line, we can write the equation of the line. Y equal to x by 2 only. Y equal to x by 2. If we use the y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. x1, y1 is 0, 0. x2, y2 is 2, 1. So this is 0, this is 0. x2 is 2. And y1 is 0, y1 is 0, y2 is 1. So y equal to x by 2. Like this equation of the straight line by joining these 2 points. Now we have the curves only. Up to here, drawing the region is completed only. Now after drawing the region, we can find the limits of the integral in 2 ways. We can find the limits of the integral in 2 ways. Here I will show you how to find the limits in 2 ways. That is both ways only. One way is like this. By drawing a line parallel to x-axis, we can find the limits. Or by drawing a line parallel to y-axis, we can find the limits only. By drawing a line parallel to y-axis, by drawing a line parallel to x-axis. In 2 ways, we can find the limits. First, I will show you how to find the limits by drawing a line parallel to y-axis. Later, I will show you how to find the limits by drawing a line parallel to x-axis. If we have another method, you can follow that. If you know other method, you can follow that one. Now here I will show you some method of finding the limits only. Okay. Now to find the limits of the integral, I am drawing a line parallel to y-axis. Our region is starting from this x equal to 0 and ending with x equal to 2. Between x equal to 0 and x equal to 2, the region is lying only. So from 0 to 2, at any point of x, we can draw the line parallel to y-axis only. At any point of x between 0 and 2, we can draw the line parallel to y-axis only. Now I am drawing the line parallel to y-axis. Now below the diagram, we start at some point and we move like this parallel to y-axis. When you move like this parallel to y-axis, the line enters the region. The line enters the region through this curve only, through this curve y equal to 0. And the same line passes through region like this and leaves the region through this. So this is the line. It is a line. Here I have drawn the line parallel to y-axis at some value of x. At some value of x between 0 and 2 only. After 0, before 2, at any value of x, we can draw the line only. Like this one. When you draw the line parallel to y-axis, the line enters the region through this curve and the same line leaves the region through this curve. So this is entering curve. This is called entering curve and this is the leaving curve only. This is entering curve. And this is leaving curve. Through this curve, the line is entering the region only. Same through this curve, the line is leaving the region. That is why this is called entering curve. The first curve is called entering curve. The second curve is called leaving curve only. So it is entering curve, first curve, or lower curve. This is called second curve, leaving curve, or upper curve only. Right? Now here, this line is drawn at some value of x. Line is drawn at some value of x. At this x, y is changing from this point to this point on x. At this value of x, y is changing from here to here only. Suppose if I draw the same line at this point of x, y will vary from this point to this point only. Suppose if I draw the line at this point of x, y will vary from here to here only. Like this, we can draw the lines from 0 to 2 at any point. For each x, y will vary from this point to this point, or this curve to this curve. If you observe all the heights here to here, here to here, here to here, here to here, all the heights parallel to y-axis are not same. From this point to this point, this point to this point, all the heights are not same. So the height is changing only. For each x, height is changing only. So from these two curves, entering and leaving curve, we can find the limits of variable y. The line is drawn parallel to y. Here x is fixed, but y is changing only. From this, we can write the equation of the curve, and also we write the limits of the y. So if you draw the line parallel to y-axis, this line will give the limits of y. Line will give means this entering curve will give the lower limit, this leaving curve will give the upper limit. The equation of entering curve is y equal to x by 2 only. And we are finding the limits of y. From this equation of the curve, write the y in terms of x. It is already y in terms of x only. So upper limit is y equal to x by 2. And from this entering curve, we can write the y in terms of x. The equation of this curve is y equal to 0. From this, y equal to 2 only. So the line will start from y equal to 2 and ending with y equal to x by 2 only. Like this, we can draw the lines from 0 to 2. For each value of x, y will vary from 2 to x by 2 only. Y will vary from 2 to x by 2 only. These are the y limits only. Just draw the line parallel to axis, get the limits like this. These are the limits for y. Like this, we can draw the limits. We can draw the lines parallel to axis from x equal to 0 to x equal to 2, because the region is starting from 0 ending with 2 only. So these are the x limits only. For each x from 0 to 2, we can draw the lines parallel to y-axis. So this line parallel to y-axis is giving the limits of y only. These are y limits. These are the x limits only. Now here limits are x equal to 0 to x equal to 2, y equal to, this is not y equal to, here y equal to 0. This equation is y equal to 0 only. Sorry, not y equal to 2 only. Y equal to 0 to y equal to x by 2 only. So this is the method of finding the limits of the integral by drawing a line parallel to y-axis. Line is parallel to axis. In the same way, we find the limits by drawing a line parallel to x-axis also. Again, I draw the diagram and I will show you how to find the limits by drawing a line parallel to x-axis only. Now I'm drawing once again the same diagram. Y-axis, x-axis, triangular region, O 0, 0, A 2, 0, B 2, 1. The equation of y-axis is x equal to 0. Equation of this line is x equal to 2. equation of this is y equal to 0 and this height is 1. So y equal to 1, this height is. And the equation of this line segment is y equal to x by 2 only, or is a region. Up to here, drawing the region is completed only. Just now I have shown the method of finding the limits by drawing a line parallel to y-axis only. Like that here, by drawing a line parallel to x-axis, we try to find the limits only. And remember one point here, always draw the line parallel to y-axis in increasing direction of y-axis. Always draw the line parallel to y-axis in the increasing direction of y-axis. Increasing direction of y-axis means from down to top only. If you go down, that is negative direction. If you go up, that is positive direction. That is increasing direction. Down to top. We start at this position, we move like this upside only. Down to up. This is a positive direction. Next, parallel to x-axis. First of all, along the x direction, increasing direction is right direction. Along the x-axis, increasing direction is right direction. And decreasing direction means left side only. So from left to right, we draw the line parallel to x-axis only. This is the region of integration. Before the diagram, we start at some point and we draw the line parallel to x-axis in the increasing direction of x-axis like this one. Now I'm starting at some point before the diagram and we are moving like this parallel to x-axis in increasing direction, that is right direction. When you move like this parallel to x-axis, the line enters the region through this curve. So it is entering curve, first curve, left curve. Next, the same line passes through region like this and leaves the region through this line segment only. So this line segment is leaving curve, this line segment is entering curve only. The line is drawn parallel to x-axis in the increasing direction of x-axis only. So this is entering curve, this is leaving curve. This line is drawn parallel to x-axis at some point of y. At y equal to something. This is the line at y equal to 0. It is the line at y equal to 1. Like that, this is the line at y equal to something only. Here y is fixed, but x will vary from here to here only. But in the previous diagram, here x is fixed. For each fixed x, y will vary from here to here only. Like that here, for this y, x will vary from here to here only. Or x will vary from this curve to this curve only. Suppose if I draw the same line at this point of y, here y is fixed, but x will vary from here to here only. Suppose if I draw the same line at this point of y, here y is fixed, x will vary from here to here only. For each y, the lengths of these are not same. This length is not same as this length is not same as this length. All the lengths are different, and that is x is changing only. For each y, x is changing only. In the previous diagram, for each y, sorry, for each x here, y is changing, and in this diagram, for each y, x is changing only. So this entering curve will give the lower limit. This leaving curve will give the upper limit only. This leaving curve will give the upper limit. The entering curve will give the lower limit of x, because this line is drawn parallel to x-axis. This line parallel to x-axis will give limits of x only. From this equation of the curve y equal to x by 2, write the x in terms of other, because the line parallel to x will give the limits of x only, because x is changing only. That is why from this equation of the curve we write the x in terms of other. X equal to 2y. From this leaving curve x equal to 2, we write the x in terms of other, that is x equal to 2 only. Y equal to x by 2. From this we write the x equal to 2y. Here x equal to 2 only. So this entering curve and this leaving curve will give the limits of x only. Entering curve will give lower limit, leaving curve will give the upper limit. Like this, we can draw the lines parallel to x-axis from y equal to 0 to y equal to 1. We can draw the lines from y equal to 0 to y equal to 1, because our region is starting from y equal to 0 and ending with y equal to 1. Like this, we can find the limits on. We can draw the lines from 0 to 1. So y will vary from 0 to 1. These are the x limits, these are the y limits on. Here the limits are y equal to 0 to y equal to 1, x equal to 2y to x equal to 2 onwards. These are the limits. Like this, we can find the limits in two ways. By drawing a line parallel to y-axis, we can find the limits. By drawing a line parallel to x-axis, we can find the limits in two ways. Whatever you choose, we get same answer. Always, you need not to find in both ways, not required only. We choose one of the way and we try to find the limits. Now let us consider the line parallel to y-axis. Remember this, line is parallel to y-axis means y is changing here. Here line is parallel to x means line is changing. X is changing only. Parallel to x-axis, x is changing. That is why x limits are variable limits. Line is parallel to y-axis, y is changing. That is why y limits are parallel. Y limits are variable limits only. Parallel to y-axis, y limits are variable limits. So we start with integration y variable. Line is parallel to x-axis, x is changing. X limits are variable limits. That is why we start with the integration x on. Right? Now again we do this problem. Now, before going to do this problem, just look at this diagram. X-axis, y-axis. Suppose this is x equal to 4. This is x equal to 9. This is y equal to 0. And this line is parallel to x-axis. So this is at some y equal to 4 like this, or 8. It is the equation of the line y equal to 8. Its equation of the line is x equal to 4. Its equation of the line x equal to 9. Its equation of the line is y equal to 0. And if you observe this region, this is a rectangular region. It is a rectangular region only. In the previous problem, non-rectangular region, non-rectangular region, non-rectangular region. But in this region, R is the region, and this is just like rectangular region only. Suppose for a given problem, the region is given like this. The region is given is like this only. The given region is like this only. Then we try to find the limits by drawing a line parallel to axis or parallel to x-axis, just like the previous problem only. Let us draw the line parallel to axis. Our region is starting from x equal to 4 and ending with x equal to 9. The region is lying between 4 and 9. So from 4 to 9 at any point of x, we can draw the line parallel to axis. If I draw the line like this parallel to y-axis in increasing direction, the line is entering the region through this curve. So this is entering curve. This entering curve will give the lower limit of y. And this leaving curve will give the upper limit of y. If you draw the line parallel to y-axis, this line will give the limits of y. From this equation of the curve y equals 0, we are the y in terms of other. From this equation of the curve, we are the y in terms of other. Like this, we can draw the lines from 4 to 9. So these are the x limits. Here x limits are 4 to x equal to 9 and y limits are 0 to 8. 4, 9 constants, 0, 8 constants. All the limits are constants. So remember one point. For in the case of double integral, the region is rectangular region. Region of integration is rectangular region, or given region is rectangular region. The limits are always constant. Whenever the region is non-rectangular region, the limits are always variable limits. That is why we'll have only two types of region. One is rectangular region, other one is non-rectangular region. If it is rectangular region, limits of the double integral are always constants. Non-rectangular region, limits are variable limits. That may be y variable limits or x variable limits. These are the possibilities. So same thing for triple integral also. In the case of triple integral, the 3D object is cuboid, limits will be constants. The object is cuboid, then the limits will be constant. Non-cuboid limits are variable limits. Here, two-dimensional plane region, for that triple integral, three-dimensional object. Okay, let us do the problem. Because already we know the limits. Now I equal to double integral over r x y square dr equal to xy square dr. Let us find the value of the integral by using the line parallel to y-axis. When line is parallel to y-axis, the y is changing means variable limits for y on. So we start with the variable y and then we stop with the x only. X equals 0 to 2. X equals 0 to 2. Inside the integral y equal to 0 to x by 2. X y square dy then dx, which implies I equal to integral x equal to 0 to 2. Do the inner integral with respect to y by treating x as constant. Integral of y square is y cube by 3 from 0 to x by 2 dx. This is equal to integral x equal to 0 to 2 x by 3 into, in place of y upper limit, x by 2 power 3, that is x cube by 8 minus 0 dx. I equal to 1 by 24 is constant outside. X power 4 integral is x power 5 by 5 from 0 to 2 only. Therefore, I equal to 1 by 24, upper limit is 2 power 5 by 5 minus 0. It is the value of the integral. Or you can simplify this. Like this, we can do the integral by taking these limits also. The line is parallel to axis, we start the integration with the y because y is changing. That is why y limits are variable limits. If you consider the line parallel to x-axis, then x limits are variable limits, and then start the integration with the x on. It is only difference. So whenever region of integration is given, limits are not given, we try to draw the diagram like this, and we try to find out the limits. But we can choose any one, either line parallel to y or line parallel to x. Don't take both. Okay, let us go to the problem number 4. I think this is the 4. Next problem is 5. The value of integral 0 to 1 integral x to 1 e power y square dy dx is. And the options are option A, E, option B, E minus 1, option C, E plus 1, option D, 1 by 2 into E minus 1. It is a given problem. Again, it is a double integral. Again, it is a double integral. Integral are given. Whenever the limits of the integral are given, check the limits are constant limits or variable limits only. Check the limits are constant limits or variable limits. For first integral, limits are constant. For second integral, lower limit is with variable, upper limit is with constant. So we are given as variable limits only. It is a function of x only. It is a function with the variable x. Whenever it is a function of x or function with the variable x, these limits for variable y. If it is for y, then it is for x only. So x limits are constants, y limits are variable limits. That is why we should start with the variable y and then stop with the constant limits x only. So from the given integral, we write the order of integration and then we evaluate only. Let I equal to integral x equal to 0 to 1. Inside this integral y equal to x to 1 e power y square dy and then dx. It is a given integral. According to given limits, it is the order of integration. According to this given order of integration, we should start with the variable y and then stop with x only, because x limits are constants and y limits are variable limits. Then what is the integral of e power y square? We know that integral of e power x, we know that integral of x into e power x, we know the integral of x into e power x square, we know that these integrals. Now here we require the e power x square only. We require the integral of e power x square only. Now here, to find the integral of e power x square, we don't have any analytical method only. We don't have any method only. So this function is not integrable. If it is not integrable, then this function is called non-integrable function. We can integrate this function. We can integrate this function. We can integrate this function because the method is available, method is available, method is available. If you are able to integrate the function, then that function is called integrable function. If you are unable to integrate the function, this function is called non-integrable function only. In the given problem, according to order of integration, we have to start with y, but this function is not integrable only. That is why we cannot integrate here only. But in every option, some constant value is given. That is, we require the value of this integral. From the given integral, if you are unable to integrate like this, according to order of integration, then change the order of integration. If you are unable to integrate according to given order of integration, then change the order of integration or change the limits and then evaluate. So this method of evaluation is called change of order of integration. Change of order of integration only. So if you are unable to evaluate or if you are unable to integrate the given function according to order of integration, then you have to change the order of integration. According to given order, first you have to start with y and then stop with x only. But not possible only. Integration is not possible. That is why you have to change the order. After changing the order, first you have to integrate with respect to x and then with respect to y only. Now to change the order of integration, first you have to consider given limits, and from the given limits we draw the diagram. After that we try to find the new limits of the integral. Remember the point, changing the order of integration is same as changing the limits. If when you change the order of integration, the limits will change. That is why changing the order of integration is same as changing the limits only. That is why we try to find the new limits of the variables. Now first we are the given limits. X equal to 0 to x equal to 1. Y equal to x to y equal to 1. These are the given limits. According to these given limits, we draw the diagram. X is ranging from x equal to 0 to x equal to 1, or x region lies between x equal to 0, x equal to 1 line. And the y is varying from this curve to this curve only. Let us draw the diagram. Y-axis, x-axis. The equation of x-axis, x equal to 0. X is changing from x equal to 0 to x equal to 1. The starting line for x is x equal to 0. Ending line for x is 1. This is x equal to 1. Next, y is changing from x to 1 only. Y equal to x. Y equal to x line like this. And y equal to 1. This is the y equal to 0. Equation of x-axis, y equal to 0. At some value of 1, y equal to 1. This is y equal to 1. This is y equal to x. So y is varying from y equal to x to y equal to 1. Y is varying from y equal to x to y equal to 1. X is varying from x equal to 0 to x equal to 1. Our region is this. This is the region of integration. Here, y limits are variable limits. That is why the line must be parallel to y-axis only. Here, according to given integral limits, the line must be parallel to y-axis only. This line is parallel to axis. When you draw the line parallel to axis, the line enters the region through this curve. So y equal to x is the lower limit only. The same line is leaving the region through this y equal to 1. That is why upper limit is 1 only. And we can draw the line, we can draw these lines from 0 to 1. That is why x limits are 0 to 1 only. According to limits, it is a diagram only. Another way here, changing the order is same as changing the limits. Changing the limits is same as changing the line. According to given limits, the line is parallel to y-axis. If you are given line is parallel to y-axis, you have to change the line parallel to x-axis. We are changing the line from parallel to y to parallel to x-axis so that we can get new limits only. It is a diagram according to given limits only. To change the order of integration, consider the line parallel to x-axis. Because we are given the line parallel to y-axis. That is why we are changing the line parallel to y to parallel to x-axis so that we can get new limits. Again, we draw the diagram, we consider line parallel to x-axis. This is y equal to x, this is y equal to 1, y equal to 0, y equal to 1. It is our region of integration. Drawing the diagram is completed. Let us draw the line parallel to x-axis in increasing direction, that is left to right direction. For line parallel to x-axis means down to up only. Now, before the diagram, we start at some point and we move like this parallel to x-axis in increasing direction. When you draw the line parallel to x-axis, the line enters the region through this curve x equal to 0 only. The same line passes through region and the line leaves the region through the curve y equal to x. This is the line parallel to x-axis. This line is entering the region through this. So this entering curve will give the lower limit. This leaving curve will give the upper limit of x only. Like this, we can draw the lines from 0 to 1. We can draw the lines from 0 to 1 because the region is starting from y equal to 0, ending with y equal to 1. That is why these limits are y limits. Y will vary from 0 to 1 and x will vary from the equation of this leaving curve is y equal to x. From this leaving curve, write the x in terms of other, that is x equal to y. From the equation of entering curve is, x equal to 0, we write the x in terms of other. So x will vary from 0 to y. For each y 0 to 1, for each y 0 to 1, x will vary from 0 to y. The new limits are here. The new limits: y equal to 0 to y equal to 1, x equal to 0 to x equal to y. These are the new limits. According to given limits, line is parallel to y-axis. To find the new limits, consider line parallel to x-axis. Suppose from the given integral, line is parallel to x-axis, then consider line parallel to y-axis. Just to change the line only. Changing the order of integration is same as changing the limits. Changing the limits is same as changing the line only. If you are given line parallel to axis, consider line parallel to x-axis. Or if you are given line parallel to x-axis, then consider line parallel to y-axis. That's all. It is only difference. With these new limits, possible to evaluate, we can evaluate. Now we consider given integral in the next page. I equal to integral x equal to 0 to 1, y equal to x to 1, x equal to 0 to 1, y equal to x to 1, e power y square dy, and then dx. Now this will be changed to new integral y equal to 0 to 1, x equal to 0 to y. After changing the order of integration, it is a new integral. According to given integral limits, we cannot integrate this function. That is why we are changing the order of integration. Y to x to y. Have to start with x and then stop with y only. While integrating the function with respect to x, we treat other variable y as constant. That is why e power y square is constant. E power y square is constant. Which implies I equal to integral y equal to 0 to 1, e power y square is constant because we are integrating inner integral with respect to x. Integral of 1 with respect to x is x from 0 to y dy, which implies I equal to integral y equal to 0 to 1 e power y square y minus 0 dy. Now this is integrable because we know the integral of x into e power x, and we know the integral of x into e power x square. If we take x square equal to t, then 2x dx, that is x dx on. Or directly we can write 1 by 2 into integral y equal to 0 to 1 to y e power y square. Derivative of y square is 2y. So therefore I equal to 1 by 2 into integral of this is e power y square from 0 to 1. This is equal to 1 by 2 into for upper limit e, lower limit 1. Since integral of e power f of x into f dash of x dx equal to e power f of x. So it is a 2019. It is a 2019 GATE question, 1 mark question. Just observe this integral. It is similar to this problem only. It is similar to this problem. Integral 0 to pi, integral y to pi. For one of the integral limits are constants, other integral limits are variables only. It is a function of y. Because of this, these are the x limits only. These are the x limits. These are the y limits. Because of the x limits are variable limits, we have to start the integration with the first x variable and then have to stop the integration with the y. But this function is not integrable If we have only integral of sine x, we can integrate. If we have only integral of 1 by x, we can integrate. Or if we have x into sine x, we can integrate. But sine x by x is not integrable only. We cannot use integration by parts formula. And also we don't have the integral of u by v method. Division rule is not there for integral only. So this function is not integrable. That is why you have to do this problem by changing the order of integration method only. It is the last year GATE question, 1 mark question. In the year 2020 also, one question was given from multiple integral, that is a 2 marks question. Later we write that problem. Okay, later you try this problem also. Next, problem number 6. Problem number 6. The volume under the surface z equal to 3 plus x square minus 2y over the region capital D defined by 0 less than or equal to x less than or equal to 1 and minus x less than or equal to y less than or equal to x is. Now it is a problem. Like previous problems, integral is not given, just written problem is given. And we are asked to find the volume under the surface over the region D, bounded by this. That is from the given problem, we are asked to find the volume of the region. Yesterday we have discussed about double integral, single integral, and triple integral only. Single, double, triple. Single, double, triple. Single integral is same as definite integral or ordinary definite integral. We can call this single integral as definite integral or ordinary definite integral. Next, double, triple. We have 3 types of integral: single, double, triple only. Single integral gives area. Double integral gives volume. Triple integral gives hypervolume in higher dimension spaces, 4-dimensional space. Okay, but to find the area, we can use the single integral, ordinary definite integral, or double integral. Double integral means with some condition, star. Similarly, we can find the volume by using the double integral, or triple integral means star, some condition. With some condition, we can use triple integral also for finding the same volume only. So in general, volume is given by double integral, but with some condition, we can find the same volume by using triple integral also. So here we are asked to find the volume. We can find this volume by using double or triple only. Right. Now we are asked to find the volume. Volume is given by double integral over region R. Instead of region R here, we are given D. Instead of R, we are given D. That is the only difference. Region D, f of x comma y, d x dy, or volume is given by triple integral over v f of x y z dx dy dz, where f of x y z equal to 1 only. To find the volume of the region, we can use triple integral or double integral, but the function should be 1 only. So instead of writing this directly, we can write the here 1. That's to find the volume. If we want to consider double integral, we consider like this. We consider like this. And to find the same volume, if you want to consider triple integral, we consider triple integral like this. It is the only difference. Whatever we choose, we get same answer. Okay. Now, if you want to find the volume by using double integral, we require the limits of x and y. In the given problem already, limits of x and y are given because we always evaluate double integral over the plane region. That plane region will be on coordinate plane, xy plane or yz plane or zx plane. That depends on the function. Here we are given z in terms of x and y. Z equal to f of x, y. This is why xy. This d will lie on xy plane only. Z, y, x. Some object is in space. Its equation of the surface z equal to f of x comma y, and then its projection will be on xy plane. And here we are given this as a d region, and this will be bounded by this is 0 less than or equal to x less than or equal to 1. Next, minus x less than or equal to y less than or equal to x. This region is given by this. So we always find the volume of the space region by using the double integral only. Or if you want to find the same volume, we can use triple integral also only. If you want to find the volume by using double integral, we have to consider the function and you have to take the xy limits only. Already xy limits are given. Directly d is given by 0 to 1 minus x to x. So integral x equal to 0 to 1. X is varying from 0 to 1. Y is varying from minus x to plus x. And the function f of x comma y, that is z equal to f of x comma y, z equal to f of x comma y function is 3 plus x square minus 2y dy and then dx. That's all. Directly we can evaluate. If you evaluate this, we get the volume of the region. Or if you want to evaluate the, that is if you want to find the volume by using triple integral, we require the triple integral limits. Already we know the x limits, y limits, which are given already. And just we have to find the z limits only. This is equal to integral x equal to 0 to 1. Inside this integral y equal to minus x to plus x. Inside this integral z equal to, we require the z limits only. In the fourth problem, today's first problem. Today's class first problem. Already I have shown how to find the limits of the integral from the given region of integration. If it is double integral, the region is plane region. For that plane region, drawing a line parallel to y-axis or parallel to x-axis, we can find the limits. In the same way, for triple integral, the region will be 3D diagram only, like this 3D object only. For this 3D object, by drawing a line parallel to x-axis, we can find the limits. Or by drawing a line parallel to y-axis, we can find the limits. Or by drawing a line parallel to z-axis, we can find the limits. Here already xy limits are already known. Already xy limits are known. Just we need to find the z limits only. To find the z limits, we should draw the line parallel to z-axis only. We should draw the line parallel to z-axis only. Now this is our given object. Main object is this is a given object only. Its surface is given by z equal to f of x comma y equal to 3 plus x square minus 2y. Its projection is on xy plane, that is given by these two only, 0 to 1 minus x to x. So for this total object, the top surface is given by z equal to f of x comma y. The base surface is given by this region only. And the equation of this base plane, is z equal to 0. Because this base of this object is on, the projection is on xy plane. The projection is on xy plane only. So equation of this xy plane is z equal to 0. And the equation of this surface is z equal to f of x comma y. We should draw the line parallel to z-axis in the increasing direction of z-axis only. We should draw the line parallel to z-axis in the increasing direction of z-axis. So base of this is on XY plane. Just below this diagram, we start at some point. We start at some point like this. We move parallel to Z axis only. It is a line drawn parallel to Z axis through this. That is below this region, we have started at some point and we are moving like this parallel to Z axis. When you move like this parallel to Z axis, this line enters this volume region. This line enters the volume region through this base plane, and the same line passes through this region, and it leaves the region through this top surface only. The bottom surface equation is Z equal to 0. The top surface equation is Z equal to f of x, y only. From this Z equal to 0, we'll get the lower limit. From this Z equal to f of x, y, we get the upper limit only. If you draw the line parallel to Z axis, the line enters this space region through this base plane, and same line leaves the region through this top surface only. So the base surface will give the lower limit for Z, the top surface will give the upper limit for Z only. Equation of the base plane Z equal to 0, equation of the top surface is Z equal to 3 plus x square minus 2y. So here Z limits are 0 to 3 plus x square minus 2y. The function is 1 dz, dy, and then dz. So this is dx on. Like this, we write the limits on. In the double integral, function is 1. This integral is same as single integral only. Double integral with the function 1 is same as single integral. That is why the value of this double integral with the function 1 is same as the value of the single integral. That is why both will give the same value. That is area of the region. In the same way, inside the triple integral, function is 1. The value of this triple integral will be same as value of this double integral only. That is why both will give same value. That is why this is the volume only. Both will give same value. Whatever you choose, we get same answer. Okay, we'll start here. Even if you start with the triple integral, we'll reach this double integral only. That is why both will get same value, or both will give same value only. Okay, let us do this problem, triple integral only. Now v equal to integral x equal to 0 to 1, inside integral y equal to minus x 2 plus x, integral of 1 with respect to z, or we write once again, v equal to integral x equal to 0 to 1, integral y equal to minus x2 plus x, z from 0 to 3 plus x square minus 2y, dy, and then dx, which implies v equal to integral x equal to 0 to 1, integral y equal to minus x2 plus x, for upper limit 3 plus x square minus 2y minus lower limit 0. Double integral, triple integral is reduced to double. This double integral x equal to 0 to 1. Integral y equal to minus x2 plus x only. Here the limits are just like minus x2 plus x only. So we can check the function is even function, odd function only. We are integrating with respect to y means other variable is constant. 3 is constant, x is constant, x square is constant. 3 plus x square is constant. Every constant is even function. This is the even function. So we can add it 2 times. 2y is odd function. With respect to y, the function is this 2y. This is constant. 2y is odd function, so its value is 0 only. This is a constant because we are doing with respect to y. Every constant function is even function. And we are integrating with respect to y. So it is a function of y, and this function is odd function. Integral minus x2 plus x, odd function is 0. Then for even function, it is 2 times on. 2 times integral y equal to 0 to x 3 plus x square dy and then dx on. This is equal to integral x equal to 0 to 1, 2 into 3 plus x square is constant. Integral of 1 with respect to y is y from 0 to x dx equal to integral x equal to 0 to 2, 6 plus 2x square into upper limit x minus lower limit to 0 dx. Triple integral is reduced to double integral to single integral. Finally, we require the value of this integral, which implies v equal to integral x equal to 0 to 2. The function is 6x plus 2x cubed dx. Therefore, v equal to 6x square by 2 plus 2x power 4 by 4 from 0 to 2 equal to. We'll get the answer. Here the answer will be 7 by 2 onwards. For this problem, answer is this. That is, it is a volume of the given region, or it is a volume of the region under the surface above its projection. Projection is given by this. Right. Next problem, problem number 7. Next problem, problem number 7. The area of the region bounded by the parabola y square equal to 4x and the line y equal to 2x minus 4 is. It is similar to previous problem, but here it is area, the previous one is volume. It is only difference. So to find the volume, we can use double or triple. Triple integral means we consider the function as 1. In the same way, to find the area of the region, we can use single integral or double integral. Let us find this area of the region bounded by the parabola and the line by using double integral only. given that R is a region bounded by y square equal to 4x, say this 1, and y equal to 2x minus 4, say this 2. Now to find the area of this region, first you have to draw the diagram. For drawing the diagram, we should know the boundaries, or we should know the points of intersection of these two curves only. Let us solve these two for points of intersections of curves only. Substituting 2 in 1 or substituting 1 in 2, we can find the x, y values so that we can get the points of intersections only. Let us substitute 2 in 1. We get 2x minus 4 square equal to 4x. Or in place of y, we are writing 2x minus 4. First of all, 2 is common here. If you take the 2 outside, it becomes 2 square, 4. 4 get cancelled. Directly, this is just x minus 2 whole square equal to x on, which implies x is square minus 4x plus 4 equal to x, which implies x is square minus 5x plus 4 equal to 0. 1 into 4, x square minus 4x minus x minus plus 4 equal to 0. So x equal to 1 and x equal to 4. If you know the x values, we can add the y values. If x equal to 1, then y equal to 2x minus 4 gives x equal to 1, 2 minus 4 minus 2. If x equal to 4, then y equal to 2x minus 4 gives x equal to 4, 8 minus 4, 4. Therefore, the points of intersection of 1 and 2 are 1 comma minus 2 and 4 comma 4. These two are the points of intersection. So we draw the diagram, and from the diagram we try to find out the limits. Then we evaluate the integral to write the area of the region. X-axis, y-axis. Y square equal to 4ax form only. Y square equal to 4ax form. It is a parabola. Other curve is line, straight line only. Now this straight line intersects this y square equal to 4x at 2 points. 1 minus 2, 4, 4. X equal to 4, x equal to 1. This is 0. X equal to 1, 2, 3, 4. 4 comma 4. 1, 2, 3, 4. At x equal to 4, y equal to 4, like this. Next other point is at x equal to 1, y is minus 2 only. So this is minus 1, this is minus 2 only. At 1 minus 2 only. Right? It is a line. This is one point of intersection. 1 comma minus 2. Other point of intersection is 4 comma 4. Finally, our region is this. Is the region. It is a region. Between these two curves, whatever we have the region, we have to find the area of this region only. This is y equal to 4. This is y equal to minus 2. This curve is y equal to minus 2. This is the y equal to 4 on. Now to find the limits of the integral, let us draw a line parallel to x-axis on. We can draw the line parallel to y-axis, or we can draw the line parallel to x-axis. Let us find the limits by drawing a line parallel to x-axis. Before the diagram, we started some point and we move like this parallel to x-axis. When you move like this parallel to x-axis in increase in direction, the line enters the region through this parabola curve. And same line passes through the region and leaves the region through this straight line only. Here the straight line is y equal to 2x minus 4. Line is drawn like this. For each value of y, x will vary from here to here only. X limits are changing only. X is changing only. Because for every y, x lengths are not same. So we can get the x limits as variable limits on. Like this, we can draw the lines from this line to this line. So y will vary from y equal to minus 2 to y equal to 4. The limits are y equal to minus 2 to y equal to 4. Next, x limits are x equal to. This entering curve will give the lower limit of x. Leaving curve gives the upper limit of x on. From this equation of the curve, write the x in terms of other. So x equal to y square by 4. X equal to y square by 4. Next, from the leaving curve, equation of the leaving curve is y equal to 2x minus 4. And from this x equal to 2x equal to y plus 4 by 2. So x will vary from this curve to this curve only. Y will vary from this to this one. X limits are y square by 4 to x equal to y plus 4 by 2 only. These are the limits. Now using these limits, we write the area of the region. Okay. Now to find the area of the region using double integral, inside the double integral, we should choose the function as 1. Area is given by double integral over R1 dx dy. That's equal to integral y equal to, from the limits minus 2 to 4, integral x equal to y square by 4 to y plus 4 by 2 on 1 dy. So this is dx dy, which implies area equal to integral y equal to minus 2 to 4. Integral of this is y. So this is, we are integrating with respect to x. So x from y square by 4 to y plus 4 by 2 dy. Integral y equal to minus 2 to 4. Upper limit is y plus 4 by 2 minus y square by 4 dy. Double to single. If you use single integral, we start here only. So a equal to integrate with respect to y. Y square by 4 plus 2y minus y cube by 12 from minus 2 to 4. Therefore, area equal to, simplify this, we get the area of the region. Any one of you got same answer, 9? Okay. So this is the problem. Yes, 9 is correct because most of them have got this 9 answer. So 9 answer is correct. Okay. Let us go to the next problem. Last problem for this multiple integral topic. Problem number 8. The value of the integral double integral over r x square y square divided by x square plus y square dx dy comma where r is the region bounded by x square plus y square equal to 1 with y greater than or equal to 0 is option A equal to pi by 4, option B is pi by 32, option C is 3 pi, option D 4 pi by 32. It is a given problem. Like today's class first problem, here region of integration is not given. Region of integration is not given. Sorry, limits of the integral are not given, just region is given only. Limits of the integral are not given, just we are given region of integration. Here the region is circular region with the condition y greater than or equal to 0. That is like this. X square plus y square equal to 1. Unit circle with the y greater than or equal to 0 means above the x-axis only. X-axis, y-axis. Equation of this curve is x square plus y square equal to 1 and y greater than or equal to 0. It is a condition. Equation of the curve, equation of the x-axis y equal to 0. It is the region only upper half of the circle only, above the x-axis, semicircle region only. The radius is 1. It is a line x equal to 1. It is a line x equal to minus 1. This region is starting from x equal to minus 1, ending with x equal to 1. And if we draw a line parallel to axis, we can get the limits of y and then we write the limits of x on. Or if we draw a line parallel to x-axis also, we can find the limits. By drawing a line parallel to y, we find the limits only. Now I'm starting at some point below the diagram. We are moving like this, parallel to y-axis. When you move like this parallel to y-axis, the line enters the region through this curve. So it is entering curve. The same line passes through the region and leaves the region through this curve one. So this entering curve gives lower limit of y. This leaving curve gives upper limit of y. Like this, we can draw the lines from minus 1 to plus 1. So x will vary from minus 1 to plus 1. From this x square plus y square equal to 1, we write the limits for this. And from this equation of entering curve, we can write this limit on. The equation of entering curve is y equal to 0. From this, we write the y in terms of other. Y in terms of other is y equal to 0. From this equation of the leaving curve, write the y in terms of other. That is y equal to 1 minus x square plus or minus under root. Y equal to plus or minus under root 1 minus x square. But this curve is lying above the x-axis. Above the x-axis, total y is positive. That is why we should choose the plus only. Y equal to plus under root of minus x square. Suppose this curve lies below the x-axis, then y should be negative. In such case, we should choose the y equal to minus. It is only difference. So these are the y limits, these are the x limits only, right? And here the integral is like this. Just look at this, don't do the problem. Here the given integral is, according to these limits, you have to start the integration with respect to y first. X equal to minus 1 to plus 1 integral y equal to 0 to under root of 1 minus x square y square divided by x square plus y square dy and then dx. The screen is visible or not? Check it. I'll affect the screen. Are you able to see this? Yes, sir. Visible, sir. Is it visible or not? Yes. Okay. Now it is given problem. already have shown these limits. Now according to limits, we have to start the integration with respect to y first and then stop with the x only. Integral x equal to -1 to +1. While integrating this inner integral with respect to y, other variable must be constant. So write in x square outside. Integral y equal to 0 to under root of 1 minus x square y square. In the denominator, x square is constant, y square is function of x. I am writing it like this. Adjustment. Don't write this. Just look at this. I would like to say some point here. I'm writing the y square as y square plus x square minus x square only. So this y square plus x square divided by this is 1 minus x square divided by x square plus y square dy. Now if you integrate this, integral x equal to -1 to +1, x square is constant. Integral of 1 is y minus x square is constant. 1 by x square plus y square. We are integrating with respect to y. So while integrating with respect to y, x is constant. It is just like 1 by a square plus x square form only. So 1 by x into tan inverse of y by x only. From 0 to under root of 1 minus x square dx only. W is reduced to single only. X get cancelled. X remains here. For upper limit here under root of 1 minus x square. Again here in place of y under root of 1 minus x square only. After substituting upper limit, lower limit, we get a complicated function, and evaluation of this integral may be difficult here only with respect to x only. That is why we never do this problem in Cartesian system only. So we make it simple problem by converting Cartesian to polar coordinates. That is called change of variables only. Change of variables only. Whenever the region is circular region or ellipse region, whenever the region is circular region, ellipse region, try to convert Cartesian to polar form. Whenever the function is difficult to function inside the integral. Whenever the region is circular region or ellipse region, and check the function. The function is simple function, and if it is easy to integrate in Cartesian system, we evaluate it. If the function is difficult to function and difficult to evaluate the integral, then in such case, we make it simple problem by converting Cartesian to polar coordinates. That is the advantage of the change of variables only. So we make it simple problem by converting Cartesian to polar so that we can do this problem in easy way only. Okay. This is the Cartesian only. Now we draw the same region in polar form and we try to evaluate the integral. Already we know that the transformation double integral over r x y f of x comma y dx dy to double integral r theta f of. The transformation is x equal to r cos theta, y equal to r sin theta to convert Cartesian to polar form. The function of x and y will be reduced to function of r and theta only by replacing x with r theta, y with r sin theta only. X equal to r cos theta, y equal to r sin theta. Next into modulus of j into dr d theta, comma, where j equal to r for x equal to r cos theta, y equal to r sin theta. Yesterday we have written this transformation by change of variables only in the double integral. Just you have to remember these only. To convert Cartesian to polar, the transformation is x equal to r cos theta, y equal to r sin theta only. With a given region of integration, we try to find the limits only. It is a transformation for conversion of function xy to r and theta, and j equal to r, Jacobian only. So let us draw the diagram and we try to find the limits. In polar coordinates, the positive x-axis is same as theta equal to 0. The negative x-axis same as theta equal to pi. And positive axis is theta equal to pi by 2 only. Our region is semicircular region only. Right? So theta will vary from 0 to pi. These are the theta limits. Next, we require the R limits. Here R is radius. Always radius is positive only. So R will start from origin. And we draw the line like this, radius line. This radius line, if you start radius line from origin, that is R equal to 0. And if you extend like this radius line intersects the curve at this level. This radius line is leaving this curve only. And the equation of the curve is x square plus y square equal to 1. Okay. Now here this radius is 1. R is varying from 0 to 1 and theta will vary from 0 to this. X square plus y square equal to 1. Radius is 1 here. X square plus y square equal to r square. Radius is 1. So radius will, at theta equal to 0, r will vary from 0 to 1. At theta equal to 30 also, r will vary from 0 to 1. For theta equal to 45 also, r will vary from 0 to 1. For every theta 0 to pi, r will be 0 to 1 only. For all theta values, r will vary from 0 to 1 only. So here the limits are theta equal to 0 to theta equal to pi because of semicircular region, and radius is 0 to 1. These are the limits, sir. Now we convert our given integral. Double integral over r xy. Function is x square y square divided by x square plus y square dx dy equal to convert Cartesian to polar, the transformation is x equal to r cos theta, y equal to r sin theta. In this function of x and y, replace x with r cos theta, y with r sin theta only. It is a transformation, function of xy to function of r and theta only. R square cos square theta, next into r square sin square theta divided by x square plus y square is r square only. Or write the x equal to r square cos square theta plus r square sin square theta dr. So this is modulus of j is r into dr d theta. It is a conversion. Now simplify and we evaluate. This is equal to integral limits are theta equal to 0 to pi, r equal to 0 to 1. And if we simplify this, from the denominator only r square, from the numerator r power 5, square power 1. So r power 5 by r square, that is r power 3 into cos square sin square. We read that as 4 by 4 sin square theta into cos square theta dr d theta. Integral theta equal to 0 to pi, integral r equal to 0 to 1, r power 3. This is same as the sin square 2 theta divided by 4. Because 2 sin theta cos theta is sin 2 theta, and 2 square sin square cos square is sin square 2 theta. So dr d theta. It is double integral with the constant limits and the variables are separable. So we can separate both and we can integrate directly only. Integral r equal to 0 to 1 r cube dr. Next integral theta equal to 0 to pi. 1 by 4 is constant. Sin square theta will be written in terms of cos. Cos 2 theta equal to 1 minus 2 sin square theta only. Sin square theta equal to 1 minus cos 2 theta. But sin square 2 theta is 1 minus cos 4 theta by 2 only. D theta r power 4 by 4, 0 to 1. 1 by 8 into integral of this is theta minus sine 4 theta by 4 from 0 to pi. Then evaluate it. We get the answer for this. 1 by 4 into 1 by 8 here pi minus sine 4 pi 0 minus lower limit 0 0. That's it is the answer. So we can reduce the complexity by converting Cartesian to polar form so that we can do the problem in easy way. It is the advantage of the change of variables only. So with this problem, the multiple integral topic is completed. With this problem, multiple integral topic is completed on. Next, we start the vector calculus only. So pure calculus part, that is differential calculus, integral calculus, both are completed. Let us go to the its continuation, vector calculus. Okay, next topic is vector calculus part. In the vector calculus, we have two subtopics. One is vector differentiation, other one is vector integration. Let us start with the vector differentiation. Vector differentiation. In this vector differentiation, we'll discuss about gradient, divergence, and then curl. Along with these three, directional derivative. That's it. In this vector differentiation, we'll discuss about mainly three quantities. One is gradient quantity, next divergence quantity, and curl quantity. Along with these three quantities, we'll discuss about directional derivative also, or in short form, DD, directional derivative DD on. And then we go to the vector integration because we require all this for integration part. So in the vector calculus, we have two subtopics, differentiation, integration. Now, before going to start this vector calculus, differentiation part, first we write the results of vector algebra. For this vector calculus, whatever we require the results of vector algebra, we write all those results of vector algebra. You study that vector algebra in +1, +2 level or 11th and 12th standard only. So from the vector algebra topic, whatever we require the results, we write all those results for this calculus part only. And then we start actual vector calculus part. Okay, let us start first one. Vector algebra results. So we consider some results of vector algebra for this calculus part. let A bar equal to A1 I bar plus A2 J bar plus A3 K bar, and B bar equal to B1 I bar plus B2 J bar plus B3 K bar. B, any two vectors. So by taking these two vectors, we get all the required results of vector algebra only. But in your technical subjects, you will write like this: A1 into, instead of I bar, you write the here AX cap like this only. Instead of J bar, there you may write the AY cap like this only. Instead of K bar, you may write the AZ cap only, right? So I am not writing these. I am writing because we are discussing the mathematical results from mathematics part only. In mathematics, I write the I bar, J bar, K bar instead of AX cap, AY cap, AZ cap. I'm writing the I bar, J bar, K bar only. All are same only. Because in your core subjects, you use this I symbol for current. That is why. So because of this I symbol for current, you will write the AX cap, AY cap, AZ cap instead of writing the I bar, J bar, K bar. And also you use the J, omega or J for complex imaginary unit only instead of I. But mathematical, I use the imaginary unit as I. Here I bar, I, J bar, K bar for vector sum. Only notations are different. Then the first result is sum of the two vectors A plus, that is A bar plus B bar equal to. Add these two vectors, this vector plus this vector. When you add these two, you can find the two terms with I bar, two terms with J bar, two terms with the K bar. If you take the I bar as common, then we get the A1 plus B1 only. A1 plus B1 into I bar plus A2 plus B2 into J bar plus A3 plus B3 into K bar on. Again, if you want to find the difference of these two vectors, then just replace the plus with minus, 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 that's all. For plus, 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 plus. For minus, minus, minus. Next, second bit. The length of the vector A bar is modulus of A bar equal to under root of A1 square plus A2 square plus A3 square. The length of the vector A bar is given by. Next, third, the unit vector of vector A bar is n bar equal to, or A bar cap equal to A bar by modulus of A bar. In general, for unit vector, we use the notation A bar cap for vector A bar. But throughout our vector calculus, instead of this notation, I use the notation n bar for unit vector only. So throughout our vector calculus, we write the notation for unit vector as n bar instead of A bar cap on. Next, A bar dot B bar equal to the dot product two vectors in terms of components A1 into B1 plus A2 into B2 plus B3 on. Again, while doing the problems, we won't write again these formulae. That's why we are writing the beginning of this topic on. Next, fifth one. The same dot product in terms of angle, modulus of A bar into modulus of B bar into cos theta, or cos theta angle, cos theta equal to A bar dot B bar divided by modulus of A bar into modulus of B bar. So both are dot products 4 and 5. We can write the dot product in terms of angle this, or we can write the same dot product in terms of components. Next, sixth one. A bar cross B bar. An easy way to find the cross product, we use the third order determinant for these two third order vectors. In the third order determinant, along the first row, we write the common terms of A bar and B bar. For A bar and B bar, the common terms are I bar, J bar, K bar. Along the first row, we are writing the common terms for both A bar and B bar, I bar, J bar, K bar. Along the second row, from A bar without I, J, K, A1, A2, A3. Along the last row, from B bar without I, J, K, B1, B2, B3. And if we expand along the first row, I bar into A2, B3 minus A3, B2 into I bar minus J bar into A1, B3 minus A3, B1 into J bar plus K bar into A1, B2 minus A2, B1 into K bar. Next, the projection or component of a vector A bar in the direction of a vector is given by small p equal to A bar dot B bar by modulus of B bar. The projection of A bar in the direction of B bar, or the component of A bar vector in the direction of B bar, is given by this P equal to A bar dot unit vector. Now these are the required results for our vector calculus only. Like this, many results are there, but we are considering only the required results from vector algebra only. Next, continuation of this second one. First one is vector algebra results. Next, the second one is position vector of a point in space. Position vector of a point in space. This position vector of a point in space is required to express every position of moving object. Every position of moving object. Position of moving object as a vector only. This is useful to express every position of any moving object as a vector only. Suppose if we consider one-dimensional space. One-dimensional space means just one line. Two-dimensional space is plane region. Three-dimensional space is like this. X, Y, Z on. One-dimensional space means just one line. 2D space is plane region. 3D space is like this space region. 3D on. Now in one-dimensional space, if you consider the object, that object can move either in right direction or the object can move left direction only. Only two directions. Because of one-dimensional space, the object can move either in right direction or left direction. In general, right direction, the object moves in right direction, then this right direction will be taken as positive only. The object moves in left direction, that will be taken as negative direction. That's all, only two directions only. So object can move either in positive direction or negative direction, that is right direction or left direction, no other way only. But if you consider the same object in 2D space or 3D space, the object can move in radial direction like this only. That is why here we require the direction and also we require the magnitude only. For this, we require the vector calculus. And so this vector calculus is required to study the motion of the moving object in space, to study the motion of the objects in space only. So object moves in one direction or 1D space, we do not require any vector calculus part. Whenever the object is in 2D space, 3D space, to study the motion of that moving object, we require this vector calculus part only. That is why we require the position vector of a point in space only. So this position vector of a point is required to express every position of moving object in space as a vector. Let us consider 3D space only. Let us suppose the object is moving like this in space. Object is moving like this in space. At some time t, the position of the particle is, at some time t, the position of the particle is at this point. At some time t, the position of the particle is here only. For some time t, the position of the particle is at r like this. The object is moving like this and the positions were like this only. Right? Now to study the motion of this moving object, we should express this position of moving object as a vector. For this, we do like this. To express every position as a vector, we consider one reference point. For each position of this moving object, we consider one reference point or one fixed point. Universally to follow uniqueness, we always consider the reference point as origin or the fixed point as origin only. To express every position of moving object as a vector, we take one common reference point. That reference point will be origin only. That is why any vector from origin to this point, any vector from origin to this Q, any vector from origin to this R, so any vector from origin to this P, that is OP bar, OQ bar, OR bar, these are called position vectors only. So in general, we can say that any vector from origin to that position in space, OP bar, is called position vector of a point in space. In general, it is denoted by small letter r with a bar and defined as xi bar plus yj bar plus zk bar. For this position, x, y, z only. The position vector is this. So in space, we consider the 2 points, one point as a fixed point and other point as a variable point, moving point. This fixed point is taken as a reference point. In general, we take this reference point as origin only. And if you write the vector from origin to that position, such a vector is called position vector of a point in space, denoted by r bar and defined as like this. If a point origin O00 is taken as a fixed point or reference point, and P of x, y, z and a point P of x, y, z is taken as a point P of x, y, z is taken as a moving point or variable point in space, then the vector OP bar is called a position vector then the vector OP bar is called a position vector of a point P of x, y, z with respect to origin, and it is denoted by R bar. Therefore, OP bar or R bar equal to X I bar plus Y J bar plus Z K bar. Note point 1. R equal to modulus of R equal to under root of, that is magnitude of this vector OP bar or R bar, under root of x square plus y square plus z square. It is same as distance between origin and P only. Next, note point number 2. dr bar equal to dxi bar plus dyj bar plus dzk bar. Change in R bar, change in position vector R bar is given by dr bar. Right? Now, this is the position vector of a point. Next, after note point, its position vector of a point continuation. That is third one. Wait, I'll close the session. Just read the heading, then stop. Gradient of a scalar function. Gradient of a scalar function. That is, here we discuss about gradient quantity only. So with this, I stop the today's class. That is, today's class is completed, and we continue this tomorrow only. After completion of this vector differentiation, we start vector integration. That is the last subtopic of this calculus part. Okay. So I'm closing the session, and if we have doubts, we can ask in the doubt session class. Otherwise, we can take rest until the next class. Okay, let us start doubt session class. Hello.
Audible, sir.
Audible. You can ask.
Page number 83.
Page number 83. Okay.
Sir, here, right side below corner, here you take x is equals to 2. Why didn't you take x is equals to 0 to x is equals to 2y?
Second diagram, line is parallel to x-axis.
Yeah, sir, right. That
Whenever I draw a line parallel to x-axis, the line enters the region through this curve. What is the equation of curve? Y equal to x by 2, right? The same
Right.
line passes through region and leaves the region through the curve x equal to 2. It is the equation of the curve. The equation of this curve is x equal to, the equation of this curve is y equal to x by 2 only. So this entering curve will give the lower limit of x. This leaving curve will give the upper limit of x only. From this equation of the curve y equal to x by 2, we have the x in terms of other, that is x equal to y. From the leaving curve x equal to 2, x in terms of other is x equal to, that is why x equal to 2y to x equal to 2 only.
My concern was means it is difficult to write that second diagram, sir. Especially that second limit. Is it easy to write about whatever things, but because of the limit, the answer gets changed. That is why. Why don't you take some more sum on this, sir? Because when I used to try, I used to get stuck on this limit wala part only.
No, we will get again these in vector integration also, these models.
Okay. Sir, page 85.
No confusion, don't get confusion here. Just draw the line parallel to x-axis and get the limits of x only. This
That
line,
second limits are there only. I made mistake. I took x is equals to 0 to 2y, but there it is 2y to 2. Means 0 to 2y to. I didn't take x is equals to 2. I took 0 to.
The only thing is just consider the equation of the curve, that's all. Equation of the entering curve, equation of the leaving curve. Line is parallel to x, write the x in terms of other. If the line is parallel to y-axis, write the y in terms of other. That's all. Directly you get the limits.
Okay. Sir, page number 85. Same.
Okay.
Sir, here you took x is equals to 0 to x is equals to y. Why didn't you take x is equals to y to x is equals to 1?
You are asking about second diagram.
Yeah, new limits.
Here I have drawn the line parallel to x-axis. When I draw the line parallel to x-axis, the line enters the region through the curve x equal to 0. Through this curve. Equation of this curve is x equal to 0. Okay?
Okay.
And the same line is leaving the region through this curve. What is the equation of this curve? Y equal to x. So this leaving curve gives upper limit of x only. The entering curve gives lower limit of x only. From the equation of leaving curve, we should write x in terms of other because we are finding x limits. Line is parallel to x. Or other way, this line is drawn parallel to x-axis at this point. And this line is varying from this point to this point. But if y is fixed here, y is fixed. It is the line y equal to 0. It is the line y equal to 1. It is the line at y equal to something here. So here y is fixed. X is changing from this point to this point or this curve to this curve. And if you observe the left curve, this line is drawn at some value of x only. Here x is 0. This is the line at x equal to 0. It is the line at x equal to 1. So it is the line at x equal to something. At this fixed x, y will vary from here to here on. From 0 to 1, for all values of x, y will change like this because all heights are different. That is why y limits are variable limits here. Similarly, here, for each y from 0 to 1, for each y from 0 to 1, X is changing. All lengths are not same only. This length is not same as this length. Not
Sir,
same
in
as this.
first diagram, we firstly we take y is equals to x, and in second diagram we second time took x is equals to y.
Ah.
That is the question. This how
you-
to use that?
I already told one point. Always draw the line parallel to y-axis.
Okay.
Increasing direction of y-axis. If you draw the line parallel to y-axis, that should be drawn in increasing direction. Along the y-axis, increasing direction means upward direction.
Right.
Right. So we should start from down and we should move upward only, down to up. And for drawing the line parallel to x-axis, we should draw the line parallel to x-axis in increasing direction. Along the x-axis, increasing means only right direction, not left direction. That's why we start from left to right. Here down to up. Okay, bottom to top. Here left to right. It is a thing only.
Got it. Got it. Thank you, sir. Thank you.
If you know this point, then you can draw the limits.
Okay. Thank you, sir.
Next. Hello.
Sir,
Hello. Hello.
Hello.
Tell me.
Hello.
I'm audible. Am I audible?
85 page only. Sir,
Okay.
sir, am I audible?
Yeah, you are also audible.
Sir, here how to decide by seeing the question and limits area means how it is upper triangle, not lower triangle.
No, according to given limits only, we are drawing the diagram. Here the limits are x equal to 0 to x equal to 1. And here y is varying from x equal to 2, y equal to 1 only. Up to here, okay? These are the given limits for the integral.
Yes, sir. Yes, sir.
Okay.
Yes, sir.
That is x is varying from x equal to 0 line to x equal to 1 line. That is x region lies between x equal to 0 and x equal to 1 only. X region
Sir,
lies
actually,
between only.
Sir, here actually I'm having confusion. Here actually it will be the triangle which you have drawn or the triangle which means x
not
equal to
always
0
triangle.
to x equal to
it is not always triangle. That depends on the given limits only.
No, sir. Here in this question only I am having. Yes, sir. In this question only I am having doubt whether it is. I am not able to means make out whether it is the triangle which you have drawn or it is the triangle which is means just the opposite one means the lower triangle, sir. It will take x equal to 1 as a line. Then
I will tell you.
I will form another triangle, no, sir. So that I am having.
I will tell you. Sir. Here, just remember the limits x equal to 0 to 1, y equal to x2, y equal to 1. Okay. I will show you how to draw this. Here.
Yes, sir.
X is given that varying from 0 to 1. And y is given that varying from x to 1. That's all. Okay. Now, first we draw the x region. And then y region, we combine both. X-axis, y-axis. So, it is the equation of y-axis, x equal to 0. Other line is x equal to 1. This is x region from down to top. In minus infinity to plus infinity only. Okay. Next, similarly, y region is like this.
Yes, sir. Yes, sir.
Here, y region is starting from which line? Y equal to x. It is a line starting. Ending, what is the ending line here? Y equal to 1.
Yes, sir.
This is y equal to 0. Y equal to 0 0.1, 2, 3, 4, y equal to 1. That's it. Then we combine both. That is this. This is a region.
Okay, sir. Got it. Got it, sir. Got it.
Any other doubt?
Yes, sir. And sir, and I'm having and here we choose the means limits according to the line, sir.
According
that
to
line we have
using
to choose
line.
the limits.
Yeah. Based on line, we are choosing the limits.
Okay, sir. Okay, and sir, next in the next question.
Next.
If we choose the line parallel to x-axis, then the Sir, if we choose according to the means parallel to y-axis, it will differ. The limits will differ according to the parallel to x-axis. Then the limits will differ.
According to the line, the limits will be different, but we get same value on it. Diagram is same, limits are different
Same value.
based
Okay,
on
okay.
line, but
Sir,
we get same value.
Okay, okay. Sir,
Hello?
in the next question, sir, in the next
Problem
question,
number 5. This one.
Sir, here actually in the means in previous class you told that to find the volume we can find it by double integration or with triple integration with some condition.
Yeah.
Sir,
Condition means
can you tell what is the condition here?
condition is this one. If you want to consider triple integral for finding the value, inside the triple integral we should choose the function as 1 only. It is the only condition. If you want to consider double integral,
Sir, in every question it will be 1 only.
Yeah. Volume means that's 1. By considering the triple integral, by taking the triple integral, if you want to find the volume, then we should take the function as 1. If you want to find the volume using double integral, we should consider function f of x, it is the only difference. Even if we take this also, we'll reach this part. We'll reach this part only.
So, sir, if
hello.
Okay, sir. For means every volume integration, if we take the triple integration, the function will be 1 only.
Yeah. Similarly for double integral area also.
That's all, sir. That's all. Thank you. Okay, sir. Okay, sir. Thank you.
Hello. Hello. Tell me your question.
Answer that page 85, I guess.
85. Okay.
So here, why you took that upper line, that y is equal to x, it's all right, but y is equal to 1, why you have drawn over there? It can be x is equal to 1 also, that line.
No, are you talking about y limits or x limits?
So y limits.
In the problem, x limits are given as 0 to 1, y limits are given as x1. That is y equal to x2, y equal to 1.
Means y is varying from x to 1, so we have taken that.
Yeah. That's
in that you have given gate question there, x was changing from y to y.
Yeah.
So
Correct.
we have to take triangle on x-axis.
Yeah.
Okay. Sir, and this question itself, next page.
Next page.
Yes,
86.
yes, 86.
No. This one?
Yes, sir. Sir, here to that second last step, it is 2y e to the power y square. Second last step.
Okay. 2y into e power y square.
Yes, sir. After this, that e to the power y square direct came, that you have taken that t y square is equal to t, all that.
No, actually the function was e power y square into y only. So one method is substitution method. If you want to use substitution method, we take y square equal to t. Then its differential is 2y dy. That is one method. Or directly, if we can use this formula, we can add the integral also. If you want to use this should be derivative of this function. The derivative of a y square is 2y, but here only y is there. That is why I am writing 2 in the numerator and denominator 2 only.
Okay, so once you said that, okay. That's all.
Okay, right. Hello.
Good evening, sir.
Good evening.
Sir, page number 87F.
87. Okay. What is your doubt?
I think the previous, yes, sir. So
This
here, why did you, yes, sir. So here, how did you take the limits for Z, sir, for the triple integration? I could not understand that, sir.
Okay. Here, while discussing the double integral, I told that z equal to f of xy is the surface of some object in space only. Okay. We take the projection of that object onto xy plane. When you take the projection of this object onto plane, under this object, above the projection, we'll get some space region. Under this object, above its projection, we get some space region. The space region volume is given by this double integral only. Okay. Is it clear? Hello?
Okay, sir. Yes, sir,
Okay.
yes, sir, yes, sir.
That is why for this
Yes, sir,
object.
yes, sir, it is. Thank you, sir.
Okay. Okay. Doubt session is completed and I'm closing this session.